Hi friends, good morning. I welcome you all to the ASTRA program presented by Akka Ias Academy. In this module, I'll be discussing few basic concepts related to speed, time and distance, which will be your first test. Okay, we shall begin now. So in paper 2 Csat program, you will be having questions related to speed, time and distance, right? So here I'll be dealing with the few basic concepts, how to solve these problems and all. Okay, so first of all, you know that what is the basic formula for speed, time and distance? Speed is equals to distance upon time. This is the basic formula. Okay, so what kind of questions you can expect of based on these speed, time and distance concepts is I'll be writing here. So problems based on straight lines, second based on relative motion, and based on circular motion. Say for example there is a running track and two runners are running from the starting point with two different speeds and in the same direction, in the opposite direction. So these are based on the circular motion. And based on trains, two trains are running in the same direction, two trains are running in the opposite direction with two different speeds. One train leaves station A from say for example 12 p.m. and the second train leaves the station at 2 p.m. So what is the relative speed? So these are the questions you can expect from trains. In the similar fashion, boats, and streams. Okay, here you need to know the concept of upstream and downstream. So what how does this question works? Based upon the clocks and races. Okay, so clock hour hand is moving faster, second hand is moving faster than minute hand. So these are the kinds of question you can expect, and this race is about the circular motion itself. Okay, so these are the few basic questions what you can expect here. Okay, I'll be dealing with the concepts here. Okay, say for example, what do you mean by the displacement here? There are 2 points here. Okay, point A and point B. Okay, if at all X person is moving from point A towards point B, so then the person has moved from point A to point B is known as displacement. Okay, the person has been displaced from position A to position B. This is known as displacement. Okay, so here while moving, this X person can travel from position A to position B with different speeds, right? Say for example there is a point here C. So from A to C he has traveled with the speed S1, and from C to B he has traveled with the speed of S2. So they may ask you to find the average for the entire journey. Okay, average speed for the entire journey, or else he takes some time T1 to travel from position A to position B. From position C to position B he takes time T2. Okay, what is the speed here? So if at all some data they will be given, some two data they will be given, speed and time they will be given, they will be asking you to find the distance, whereas speed and distance will be given, they will ask you to find the time. Okay, these are all the questions you can expect here. So basic formula is speed is equals to distance upon time, or else speed into time will be equals to distance, or else this can be in the same way it can be written as time is equals to distance upon speed. So these are relative, right? The same formula can be written in three types here. Okay, now what you need to know is when speed is constant, if at all a body has been displaced, if at all two different persons are traveling in the same speed with two different distances and two different times, so what is the ratio of the speed they may ask? So no, not speed, what is the ratio of the distance traveled or time taken travel, like that they will be asking here. Okay, so for that the formula will be when speed is constant, when speed is constant, time is directly proportional to distance traveled. I'll take up an example and I'll be explaining you. One second. Say for example, a car moves for 2 hours at a speed of 25 kilometers per hour. So time is given is 2 hours, speed will be 25 kilometers. So this is a simple example, okay? Just assume here. And another car moves for 3 hours. So T2 will be 3 hours with the speed, same speed, right? Speed is constant here. Both cars are traveling with the same speed here. So find the ratio of the distance covered by the 2 cars. So find ratio of distance covered by 2 cars. So this is the question here, okay? So what they have given, time 1 is given 2 hours, time 2 is 3 hours, the speed is both in both the cases the speed is same, that is 25 kilometers per hour. So what they are asking to find the ratio of the distance covered by 2 cars. So hence speed is directly proportional to time into distance, we know that, okay? So based upon this formula we can say that time taken by first A car to travel upon time taken by B car to travel is directly proportional to the distance traveled by A car by distance covered by B car. We can equate this, right? So in these conditions, so 2 by 3 is the answer here. So this is the formula, this is the way the formula works, okay? Here speed is directly proportional to time and distance, that is when speed is constant, okay? So when in second case what happens is, when time is constant, then speed is directly proportional to distance. We can equate, right? When actually in some of the questions you will encounter 2 different datas have been given but the same t is traveled, so the time taken will be the same here. So then you can equate both the equations there, okay? Based upon while trying to solve different problems, take this as the basic concepts here, okay? When speed is constant, when t is constant, when distance is constant, whereas time is constant. So then you when 2 equations we have got, consider for example we have got 2 equations, then when time is constant the 2 equations can be equated here, okay? Say for example 30 kilometers, the same ratio, okay? Then for the same example, if at all t is taken as, for the same above example, okay, the above example t is taken as 2 hours, then speed upon by speed 2 will be directly proportional to d1 by d2. So 30 by 40 will be d1 by d2, that will be equal to 3 by 4. So for the same example, so okay, when the third condition, when distance is constant, then speed will be inversely proportional to time taken. Speed will be inversely proportional to the time taken. Say for example this distance is same, okay? 2 persons traveling from A position and from B position, that is X person and Y person, they are traveling from A position towards A. So from A position towards B, and Y person is traveling from B position towards A, okay? So this is the data given here, okay? What is the time taken for for the person X to travel from A to B? That will be T1 and here will be T2, okay? So when distance is same, right? So the X person is traveling from A to B and B person is traveling from B to A, the vice versa, the distance will be same here. So then we can equate it as S1 upon S2 will be equals to T2 upon T1 when D is constant. So these are the basic conditions or basic formula what you need to know before trying to attempt these questions, okay? So in the next page I will be discussing about the conversion here. So conversion. So this is also a simple concept here. See, in questions the data will be given. Speed will be given in kilometer per hour, time will be given in hours, okay, and distance will be given in kilometer. Okay, these are the some data they will be given. Okay, if at all some data in a question, consider for example in a question, in a single question, some data is given in kilometers per hour and some data is given and they have asked the answer will be in meters per second. Okay, then what you will do, or vice versa conditions. Okay, now we know that 1 kilometer per hour will be equal to 1000 meters, right? Not 1 per hour will be, just don't consider hour here. Okay, 1 kilometer will be equal to 1000 meter, right? So then 1000 meter by 3600. Why I wrote 3006 here? Because I need kilometer per hour is here. Okay, I need per second. So in 1 hour 60 minutes will be there, and in each minute 60 seconds will be there. So 6 6 are 36, so 3600. Okay, 1000 divided by 3600, 2 zeros gets cancelled, 10 divided by 36 equals to 5 by 18. So it is as simple as that. When they have when they have given in kilometer per hour and they are asking you to convert it into meters per second, then what you need to do, we need to multiply 5 by 18 to this kilometer per hour to get the answer in meters per second. So vice versa, if at all they have given in meters per second and asked you to find it in kilometers per hour, so then what you need to do, 18 by 5, it is reverse it. Okay, reverse it, 18 by 5, then you will be getting in kilometer per hour. This is the basic conversion technique what you need to know. Just remember 5 by 18 and 18 by 5. Okay, so in next page I'll be dealing with the relative speed. What do you mean by relative speed here? So in the first concept we have talked about when speed is constant, when distance is constant, when time is constant. 3 different concepts we have talked about. Okay, so here relative speed, if at all, consider for an example, from point A to point B, 2 persons are traveling, X person and Y person. Okay, in the same direction. X is bit faster, speed S1, and Y is bit slower. Okay, this is faster and this is slower. So what is the relative speed here? They will be asking you, the question will be based on that. Okay, relative speed will be upon 2 concepts here. If they are traveling in the same direction on the straight line, right? Okay, in the straight line, if they are traveling in the same direction, and when they are traveling in the opposite direction. Okay, movement of one body relative to another body, this is known as relative speed. Movement of one body relative to another body, this is known as relative speed. Okay, so compared to first body, the second body is faster or slower. If at all faster, then how many kilometers faster? If at all slower, then how many kilometers slower? This is the basic concepts here. Okay, if at all consider the first case, in the same direction, this is the straight line here, same distance. Okay, just for picturization sake I have drawn 2 lines here. Okay, person X travels and person Y travels from position A to position B, position A to position B. So consider for example he is traveling in 10 kilometers per hour speed. Okay, so for the first hour he will be traveling 10 kilometers, right? If at all this is the time taken for 1 hour, then what is the distance covered? This is 10 kilometer. Say for example a person traveling in the same direction Y, he is slower than 2 kilometers. He is slow for 2 kilometers, and then speed will be 8 kilometer per hour. See here, for the same 1 hour of time he will be traveling 8 kilometers, right? So what is the difference here? For the same 1 hour he will be traveling 8 kilometers, and person A will be traveling for 1 hour 10 kilometers. See, difference is 2 kilometer, right? So this is the relative speed. So in relative speed, what happens? If at all both the persons are traveling in the same direction, then relative speed will be S1 minus S2. Okay, see, for 10 kilometers he is traveling in the same 1 hour, and another person will be traveling in the 8 kilometers. So this is the difference between S1 and S2. That is, no, person 1 and person 2, the relative distance will be 2 kilometers. Hence the speed will be deducted. So what happens in second case, if at all they are traveling in opposite directions, point A and point B, person X is traveling from point A towards point B, and person Y is traveling from point B towards point A. Okay, so if at all this is S1 and this is S2, so relative speed will be, see what happens in relative speed, if at all they are traveling in the opposite direction, it adds up. S1 plus S2 is the relative speed here. Okay, so this is the basic concepts what you need to know while before solving the questions on relative speed. So in the next page I'll be dealing with the concept of trains here. Okay, trains. Basic formula, what it is? Basic formula, you know, speed into time is equals to distance. Okay, this is the basic formula here. See here you can encounter 2 or 3 types of problems here when train is crossing a moving object. Okay, see this is the track here, and train T1 is moving in this direction from point A towards point B, that is station A to station B. Okay, if at all it encounters a station here, okay, the station will be having some platform here, or on the platform a person will be standing here. Okay, so what the question will be, when train is crossing a moving object, or a train is crossing a person, or a train is crossing a platform. Okay, these kind of questions will be encountering in trains. Okay, and the second set of question what you will be encountering is, 2 trains are traveling, T1 and T2, that is in same direction or opposite direction. Okay, here the relative speed concept, you need to apply the relative speed concept here. Okay, so when train crosses an object, see the first case here, when train crosses an object. Okay, this object may be a single pole, for example a train crossing a pole, or a person. Okay, this will be the question type, or else a train crossing a platform. Or else what another type of question will be, one train is of length L1 and another train is of length L2. Okay, if at all they are crossing each other, that is they are moving in opposite direction. So what time does it take both the train to cross each other? These are the kinds of question you will be expecting in trains. Okay, so what we will do for this, when the train crosses an object, that is a still object. Okay, so then the formula will be, see, length of the train will be, so the length of the train plus object. Okay, this is the formula for the length of the train plus object here. Okay, this object, if at all it's a platform, then the length of the train L1 plus length of the platform L2. Okay, if at all length of the train L1 plus this object will be a person. Okay, so then the total length will be L1. Okay, no, the length of the human will be not L2. Okay, here if at all a person is there, so only the length of the train will be considered here. Okay, so in the same type, if at all the train T1 is traveling in this direction and train T2 is traveling in this direction. So what will be the length here? See, length of the train T1 plus length of the train T2. Okay, if at all they are crossing each other, that is opposite direction. This is opposite direction. Okay, what happens if at all they are traveling in the same direction? Opposite case. If at all they are traveling in the same direction, T1 is traveling in this direction, T2 is traveling in the same direction. Okay, and T2 is faster than T1. Okay, then train 2 will be overtaking train 1 here. Okay, train 2 will be overtaking train 1. So what is the time they will be asking here? So what will be the time? So length of the total length will be, length of the train will be speed of train T1 minus speed of the train T2. Okay, so this T2 minus T1 into time will be the distance here. Okay, this is the formula you need to apply. Okay, so see these are some of the basic concepts what you need to know before solving the problems on trains here. The same concept will be applying to boats and streams here. Okay, in the next page I will be dealing with boats and streams. So boats and streams. What happens in streams is, from point A to point B, if at all the direction of the stream is in like this. Okay, from A to B is the direction of the stream. The stream is flowing in from A to B and the direction is from A to B. So this is the direction. Okay, in this case what happens is, boat will be flowing once in the same direction, and in the second case boat will be traveling in the opposite direction. Okay, so this what do you mean by downstream here? Okay, downstream will be when the direction of the stream, okay, direction of the stream plus direction of the boat will be in the same direction. See here, if at all the speed of the stream is SS, we will be considering speed of the stream is SS and the speed of the boat will be SB. So then what happens in the downstream? Both the speed adds up here. Net speed will be S equals to speed of the stream plus speed of the boat, because they are traveling in the same direction. See, the flow of the stream adds up to the speed of the boat right here. Okay, what happens in the upstream then? Net speed will be speed of the boat minus speed of the stream. The speed will be deducting, right? This boat traveling in opposite direction of the stream needs to cut the speed of the stream, then be traveling in the opposite direction of the stream. So hence the speed will be negative here, speed of the boat minus speed of the stream. Okay, so these are the basic concepts what you need to know, and the relative speed will, all the other basic concepts what I have explained in the previous slides, those all will be applying in this problem. Okay, so upstream and downstream, when you know, then the relative speed of concept will also be applying here. Okay, so these are some of the basic concepts what you need to know before solving the boats and streams. So next, in the circular motion, next is the concept of circular motion. Okay, there is a race track here, consider it's a race track, and person A and person B are racing in the race track. Okay, with two different speeds S1 and S2. See, person A and person B both are traveling in the same direction. Okay, this is the first case, and in the second case what will happen is, person A will be traveling in this direction and person A is traveling in the anti-clockwise direction, and person B will be moving in the clockwise direction. Then it is opposite direction, right? They are traveling in the opposite direction. So what happens in this case is, the relative speed adds up if at all they are traveling in the opposite direction. So S is equals to, if at all they are traveling in the same direction, speed of person A minus speed of person B. So S is equals to speed of person A plus speed of person B. It is the formula for relative speed when they are traveling in the circular motion. And one more concept will be there. If at all, see, consider 2 or 3 persons are traveling in the same point, are traveling from this same point. Okay, they are traveling from the same point in the same direction. So with three different speeds, or two or three different speeds, S1, S2 and S3. Okay, three different speeds. So some questions they will be asking here. So after starting from the initial point, if they are traveling with three different speeds, say for example 10, 20 and 30 kilometers of speed, so after beginning from the A point, that is starting point, after which distance they will be meeting again in the circular track. Okay, for after beginning the race, then the question will be like this. Okay, after beginning in the race with three different of speeds, when they will first meet, okay, in the track. Okay, when they will be first meeting is, you need to take the LCM of 10, 20 and 30. This is the LCM of 10, 20 and 30. So what is the result here? So this result, what will come here is, they will be meeting for the first time in the circular track. Okay, this is some of the basic concepts about the circular motion. So in the upcoming next video, I'll be dealing with the problems concerning speed, distance and time. So then later on I'll be solving with the time and work. Okay, thank you for staying such long. All the best guys. We'll meet in the next video. Thank you.